Hello everyone, this is Jms Kurbah speaking. Now we'll move to the part 2 of the chapter 4 on quadratic equation. Okay, the first question here is check whether the following problem from 1 up to number 3 they are quadratic equation or not. Okay, the first one is given to be x square plus 5x minus 3 is 0. Now we have to check whether this given equation is a quadratic equation or not. Solution: the given equation is in the form of ax square plus bx plus c. See, if you look for this given equation, the given equation is already in the form of standard equation. Ax square plus bx plus c is 0. Hence, the given equation is a quadratic equation. Okay, in this number 1 up to number 3, you just have to compare whether the given equation is in the form of a standard equation or not. If it is in the standard equation, no need to give a lengthy answer. Just look at the equation, and from there itself you can say that whether it is quadratic or not. Okay, for such a simple equation, you can simply by looking at the equation you can see whether it is quadratic or not. Number 2, root 3x square minus 5x plus 1 by 3 is 0. Is this quadratic? It is, and it is a quadratic. Yes, it is quadratic equation because it is in the standard form of a quadratic equation. X square, x and constant. It is in a quadratic equation. Number 3, 2x square minus root 5x plus 7. The first term is x square, second term is having x, third term is constant. This also is having in the standard form ax square plus bx plus c. Hence, the given equation is a quadratic equation. Number 4, x square minus 2x plus 5 is 0. The same way here also, number 4 also, it is in the form of standard equation. Hence, it is a quadratic equation. Number 5 here is a little bit different here. We have 3x square minus 5x plus 7 equal to x square minus 5x plus 1. Okay, now we have to simplify first this, and then after that we can say whether it is quadratic equation or not. Okay, I have given here, they have written here the given equation is 3x square minus 5x plus 7 equal x square minus 5x plus 1. What you'll do here, you take this right hand side to the left hand side, but you need not take all of them, but you look for the similar term. You group the similar term together. Okay, the next step here, 3x square. Okay, is there any term on the right side which similar to this 3x square? Yes, there is x square on the right side. It is with positive sign. Then you bring to the left, it will be minus x square. The next term is minus 5x. Okay, is there any term on the right side with a similar? Yes, it is minus 5x. You bring to the left, it will change to plus 5x, and then the next is plus 7, and same thing 1, if you bring to the left, it will change to minus 1. Okay, the next step, what we'll do, 3x square and x square, one is plus, one is minus. Plus minus is minus, that means you have to subtract. You have 3x square minus 1x square. You remain only with 2x square. Which sign is greater? Is plus or minus? It is plus, therefore you will write as 2x square. The next here is minus 5x plus 5. Plus minus is minus again, but 5x minus 5x is how much? 0. Therefore you can cancel these two terms. The last, you have plus 7 and minus 1. Plus minus is minus, that means 7 minus 1 is 6. Look for the sign which is greater. It is positive. That means you will write plus 6 equal 0. Now, whether this equation is standard, yes or no? Is yes, because the degree of x here is 2. Remember that last time in the first part I've told you that any equation with degree 2 is a quadratic equation. Even though here is only 2 terms, but we consider this equation as a standard form. Okay, you consider this as a quadratic equation, and then we can express this equation in the standard form of ax squared plus bx plus c equals 0. How we'll do that? See, in the next as a note I've given here, 2x squared plus 6 equals 0. 2x squared, is there any term with x? There's no term with x. That means you'll write plus 0x. If you multiply 0 with x, what we'll get? We'll get 0 only. Therefore, in this term we can just ignore it, and plus 6 now is having in the standard form, isn't it? 3 terms, the first, second and the third. X squared, the power of x is 2, here power of x is 1 and the constant. But in this if you multiply 0 with x, it becomes 0. That means no need to just ignore this term. You will have only 2x squared plus 6 plus 6 equal 0. But actually is having in the form ax squared plus bx plus c equals 0, which is the standard form of a quadratic equation. Okay, now let's move to the next, which is number 6. X squared minus 4x equal x squared minus 2x. Okay, for this also, is this a quadratic equation or not? We cannot simply say whether it is quadratic or not, but we have to simplify it at first. Now x squared minus 4x equal x squared minus 2x. This is the given equation. Now same thing, you bring this x squared from the right to the left. This x squared will plus, it will change to minus x squared. Then we have minus 4x, then minus 2x. When you bring to the left, it will change to plus 2x equal 0. Now x squared, one is plus, x squared, one is minus. Plus minus is minus. X squared minus x squared is how much? 0. That means you can cancel these two terms, x squared and x squared. Remaining term is minus 4x plus 2x. Plus minus is minus. 4 minus 2 is 2. We'll have 2x. Which sign is greater? Plus minus, it is minus. Therefore, you will get as minus 2x equal 0. Why do we have to add these two? Because they are similar terms. Remember last time in the first part, which are similar, which are not similar. These are the similar terms. That's why we can add them together or subtract them as accordingly to the sign which they are having. Now here you get minus 2x equals 0. Is this a quadratic? Definitely we can say no. Why? Because the power of x here is 1, just 1. If it's 1, what it is? It is a linear equation. Okay, that also we have discussed in the first part. This given equation is not in the form of x squared plus bx plus c equals 0, which is the standard form of quadratic equation. Hence, it is not a quadratic equation. Next, we'll come to the number 2. Here also, what you have to do, we have to check whether this given equation is quadratic or not. Now, solution for this, we have the given equation is x minus 1 by x equal x squared. Okay, now what we'll do here in this part, if you want to take the LCM, below of x there is 1 as denominator. You can take the LCM and then simplify it, or you can do by this another method by multiplying throughout the equation by x. Here x is in the denominator. To get rid of this x, what we'll do, we'll multiply throughout the equation by x. When you multiply x with x, you'll get x squared. 1 by x multiply with x get cancelled, you'll get only 1, and x squared multiply with 1, you'll get x cubed. Okay, the next step. Now what we'll do, x cubed, if you bring to the left, it will be minus x cubed. So it will not looking nice if you the first time you keep negative. We'll try to make we'll try to keep this x cubed on the same side, but this left side will take to the right side. X cubed, then x squared is plus, will take to right side, will be x cubed minus x squared plus 1. And what is there on the left side? There's nothing, there's no more term. That means is 0. Therefore you will get x cubed minus x squared is plus 1 equal 0. Okay, is this a quadratic? No. Why? Because the power of x here is how much? It is 3. Is 3, it is cubic equation. Okay, and we can write like this. It is not in the form of ax squared plus bx plus c equals 0. Hence it is not a quadratic equation. Is clear to all of you? Next we move to the number 2. Number 2, what it is? The given equation is x squared minus 1 by x squared equal 3. The same process here will do. To get rid of this x squared, what you'll do, you'll multiply throughout the equation by x squared. This x squared will multiply with x squared, what you'll get? The power get added. X squared multiply x squared, you'll get x power 2 plus 2, that means x power 4. This comes from the law of indices. In the lower classes, in class 6, maybe you have come across this law of indices, but we will apply that law here. If you multiply the x power 2 with x power 2, you'll get x power 4. Then the next term, minus 1 by x squared, you multiply with x squared and x squared got cancelled, you'll get only 1. And the right side is 3 multiply with x squared, it is 3x squared. Here what you'll do, you'll take since the highest power is x4, you'll keep it as it is on the left hand side. You bring the next lower value of the lower power of x, in the x4, the next lower power come x square. You bring this as second term. This is on the right side, you bring to the left, this is plus, you will change to minus 3x square, and you have last one is minus 1. It is on the same side only of the equal sign. See this equal sign, this one is on the left, and here also is on the left side of this equal sign. Therefore minus 1 will be remain minus 1 as well. It will not change sign, since it change only the place, not change the position from the left to the right side. Okay, remember this thing, that if you are not changing the position from left to right or right to left, but if you are changing just the position of the term, the first, second, third term, the sign will not change. Okay, it's minus 1 here, remain minus 1 as well. Now, is this a quadratic equation? No, because why? The degree of the equation is 4. Or we can write as, which is not in the form of x squared plus bx plus c equals 0, hence it's not a quadratic equation. Now we come to the next, number 3. The given equation is x plus 1 by x equal 2. Okay, same thing here also we'll do by multiplying x throughout the equation. How do you know that we have to multiply by x, or we have to multiply